before we finish the 7-5 notes, what we're about to do in 7-5 is the exact same steps and approach as this right here. So I wanted to pull this up to make sure you remember the foundation before we throw the trig functions in there. This is just solving quadratics. It's quadratic because the highest exponent is 2. And remember on Friday, Thursday, whatever day it was, I'm getting my 4 days and 5 days confused. On the last school day, we refreshed you on the ways to solve a quadratic. There's factoring, if it'll factor. There's square roots, if all you see is a single x term. There's the quadratic formula, which works every time, but it's a pain in the rear. There's completing the square, which we're not doing. There's graphing, which we're not doing. You always need to check if it'll factor. This throws people off for some reason. They always want 3 terms, but honestly, when there's 2 terms, it's easier. You're just looking for it's 3 letters. Or 3 letters. You're looking to see if it has a GCF, and it does have a GCF. So this right here is factoring. I'm going to say factor out GCF. This is not the whole A times C, all that. That's not this. This is just, what do they have in common? They have an X in common. Divide an X to the front. That would leave me with X minus 1. Then you have the zero product property. This should ring a bell. Where you have something times something equaling 0. The only way to multiply 2 things together and get 0 is if one of the 2 things is a 0. And you don't know which one is a 0. One of them has to be. So you just say, okay, well then set that equal to 0 and set that equal to 0 and solve. There's nothing to solve here. That one's done. Add 1, done. So the solutions there are 0 and 1. Okay? I've already done that. That's algebra 1, algebra 2.
No, wait.
You sure? If you change your mind, just let me know. I'll be here. This one right here is where you do want to check and see if there's an initial GCF. If there's not, then you multiply A times C. You get negative 18. Factors of negative 18 that add up to negative 7. Negative 9 and positive 2. And then how you go from here to finish it varies from person to person. Some people come up here and rewrite it as 4 terms, factor it by grouping, pull the GCF out, they get their answer. Some people do the box method. Some people do the fraction method. I showed y'all a technique last semester. My 4 that have not had me in a while. There was a technique that has helped a lot of people. It's where you write your 2 parentheses to show that this is from a binomial times binomial. And you put AX in the front. AX, AX, and then you write these numbers with their signs right after it. And then you reduce, if possible. This one's done. That one's done. This one has a GCF of 3 that you just divide it away. It just goes away. So this becomes X minus 3. This was done. Comes straight down. And now you have this trinomial factored into a binomial times a binomial. And then once again, just like we were over here, we have some crap times some more crap, and we know it equals 0. So that means these 2 pieces of crap have to go to 0 to figure out what the value of X is. And then solve. Subtract 2, divide 3. Okay, that should not be new. Maybe it's rusty, but it's not new. Okay? And we are applying that directly to example 6 in your notes. Go to your 7-5 notes. Seven, 5 notes. When you first look at it, I know you're going to panic and run like the pig in Chicken Little. Please don't. We're going to dodgeball. Okay, it says solve it. You've got trig functions in here. Your angle is beta. And then it tells you a restriction. This is saying stay within the unit circle, which means we don't have to worry about the whole plus 2 pi k and all that. This means stay within the unit circle. Now, notice right here, though, this says 2 pi instead of 360, right? This means you're going to answer in radians. That's your indication they want the answer in radians. Also notice that this does have a parenthesis here, which means if in the smallest chance that you were evaluating, say, sine or cosine of 2 pi, they're telling you that that's not a viable answer because they're saying parentheses mean you don't include 2 pi. Does that make sense? There's not a bracket there. So 2 pi is not a viable answer or position on the unit circle. Okay. When you first look at this, I'm sure you probably think, I have no clue how to approach this. Change sign to what letter? Change, say it again. Is that you? Change sign to the letter Y and rewrite the whole problem. And then you now calibrated it to an algebra 2 equation, and you'll know how to solve it. So this is just y squared minus y equals 0. Because we let sine of beta equal the letter y. And that's where we got this from. Well, that looks awfully familiar. Solve that. How would you approach it? How would you solve that? Factor the GCF. Then you'll use the zero product property. Then you'll have your 2 answers. Then we'll come back in and apply the trig. So get down to your 2 answers. Remember right here we applied the zero product property. Don't forget that. I have duct tape. Yes. That or this. Look. It tears nicely from me. Well, it's just an OCD. It's just an OCD thing. You're welcome. All right, we've got this solved. We have our 2 answers, but this was not an algebra 2 equation. This was a trig function. So go back now. I'm going to draw a line to say, okay, I just I'm out of my algebra 2, now I'm coming right back to the college level. So sine of beta is 0 and sine of beta is 1. Okay, so now the question is going back to 7.5 from the last school day and 7.4. The question here is, what angle, beta, what angle has a sine value of 0? And then here it's, what angle has a sine value of 1? So this is where you need your unit circle to answer the question. And remember, we're staying on the unit circle. We're not worrying about coterminal angles. You're also looking at all 4 quadrants because we're solving it for all possible scenarios. So where is, on your unit circle, the y value 0? You can probably visualize this. Think of your unit circle, right? If it says the y value is 0, that means it's a quadrantal angle. That means it's landing on one of the axes. If y is 0, that means there's no up or down limit, right? So that means it's either 0 pi, right? Or 1 pi. Does that make sense? So you need to write this note to ask yourself. Like if you get here and you're like, I have no clue what it's asking, then write this question down until you train your brain to go from here to the answer. So where is sine equal to 0 is what you ask yourself, meaning the y equal to 0. Right, it's at 0 pi, and it's also at pi. Now come over here. This is saying, where is sine equal to 1? You should be able to visualize that. So if you got your unit circle, this was 0. So if sine is 1, that's due north, right? That's 90 degrees, which is what in radians? Pi over 2. Now, in terms of the test, I would love it if you either box these in, so it draws my attention to it, or if you just came down here and basically said, okay, so you got 0 pi, you got pi over 2, and you've got pi. Notice I put them in order. So there's 3 answers here. Let's label this slide. This was, I'll label it over here. This was solved by GCF. This problem was solved by GCF. Let's go to the next problem. It's going to be solved by, like, when I say factoring, I mean A times C factoring.
Isn't there going to be 3 pi over here?
3 pi over 2 is negative 1. Right? Put your eyes on 3 pi over 2. Look at the coordinate point. Is it 0?
Oh,
See it now? There you go.
Would we get, like, if there was a quadrant problem like this, and we didn't put 0 pi, we just put 0.
Oh yeah, no, I just do the pi to remind myself to stay with radians. And technically it is 0 pi, but you're right, like 0 is the speaking.
It sounded like beta, or like beta goes to X.
Yes. Yes. Yeah, that bothers you to change it to X. And the reason I didn't is because then some people might say, well, sine's Y. So, or change it to theta, because theta's more comfortable probably than beta. All right, let's go to the next slide. We can go ahead and label it. This is solve by factoring, and I'm just saying factoring. Oh, I'm not saying it at all. I'm spelling it wrong. Hold on. By factoring, and I'm gonna put underneath A times C. Okay, so first of all, look at the directions. Solve 2 cosine squared u equals 1 minus cosine u in, and then it gives you this. This means answer in what? Degrees. And this little parentheses means if one of your possible answers is 360, you throw it out because they're saying you can't touch this. Sorry. God, I don't even know. That was a jam when I was in school. All right. When you're looking at this, I know your first instinct is, I'm going to skip that one and come back. I'm going to underline the whole thing so that you can actually see it all. All right, so from here to here is the problem. I cannot wrap my mind around that because of the cosine u. So I'm going to change it to just x. So I'm going to let cosine u equal x. Now I'm going to draw an arrow, and I'm going to rewrite the whole thing. So it would be 2x squared equals 1 minus x. Woo, that looks a lot better. Now, you should remember from solving by factoring that you cannot multiply like a times c until it's all to one side. It's got to be equal to 0. So I'm going to take these two terms over here since that 2x squared is already positive. You might take it and you might move it to the right. That's fine. I like my leading term to be negative. So I'm just going to move these two to the left. Bump that over. They will have a sign change. And I'm going to put them in order that helps me begin the steps in factoring. Okay, so this is right back to that little preview of the rest of 7.5 notes. You're going to multiply a times c. So 2 times negative 1 is negative 2. The middle term is positive 1. What multiplies to give me negative 2, but adds to give me positive 1. Negative 1 and 2. Double check. That works. Now you decide how you want to finish it. If you factor by grouping, that is fine. That's actually the method I used to use until the majority of my students couldn't wrap their mind around grouping. So now I do the little AX binomial shortcut. So we're going to come over here and we're going to write that we're fixing to get 2 binomials. The shortcut is you copy AX, and I'm going to change colors and label this. AX goes here and here, and then the 2 numbers you just came up with go right after it. These 2 numbers right here. Okay, so AX is 2x. My numbers are negative 1 and positive 2. If your leading term was not the number 1, then one of these parentheses will always reduce. We'll say it again. If your leading term is not 1, then one of the parentheses will reduce. The converse of that is probably easier to understand. If your leading term is the number 1, these parentheses will be done right here. Because there's no GC yet. All right, so I'm going to bring this one down. I'm going to draw an arrow to say that one's done. Just bringing it down. That one's not done. What would divide away? 2. I'm going to write divide by 2, and then I'm going to come underneath it and write what I would have. I'd have x plus 1. Now you once again have zero product property. Pull these out and set them equal to 0 and solve. Then I'm ready to go back and say this was actually cosine. I'm going to change it to theta. It's technically cosine u. Cosine of some angle equals 1/2. And this is actually cosine of some angle equals -1. And this is where you ask yourself, go to your unit circle, where is cosine 1/2 and where is cosine -1? Where is cosine 1/2? Go with degrees, remember? 60 and 300. Where is cosine -1? 180. So either box your answers in right there or come over here to me and say, all right, here's my list. I got 60, 180, and 300. Okay, level up. Go to the next one. So when you first look at it, your first thought is probably, I don't know if changing cosine to x is going to be helpful here because what is also in there? Tangent. Don't you dare change tangent to y over x when you're solving because it'll be a mess. So when you look at this, your first approach needs to be, I'm going to get everything to one side and then make a decision from there. So this is 2 cosine squared tan equals tan. I'm going to subtract that second tan over. So I've got 2 cosine squared tan minus tan equals 0. Okay, don't overthink this. What do you notice they both have? They both have a tan. Right? Just treat it like a block that is a common factor. So divide that to the front. If I divide a tan x to the front, now I only have the tan the one time because I just divided it. And I'd be left with 2 cosine squared minus 1. You still have to have a binomial here, okay? Because it came from a binomial. And then now, once again, you have your 3 words. What's it called? You now have your zero product property. If you can't see it, let me use a highlighter to show it to you. You have something times something equaling 0. So use the zero product property because that takes these 2 messes that are totally different trig functions and separates them. And now I have just a single equation with tan. So this becomes tan x equals 0. And then I have 2 cosine squared x minus 1 equals 0. Now they're in totally different equations. That's already by itself, right? Tan x equals 0. This is not. Add the 1. Divide by 2. Now you've got it down. Cosine squared x equals 1/2. What do I need to do there? Can't leave it at squared. It needs to be just a plain trig. So you're going to go and take the square root of both sides. And what needs to populate on the next answer? What needs to pop up? Plus or minus right here. And then this becomes just plain cosine. Remember from the last school day, the square root of a fraction can be separated into the square root of the top and the square root of the bottom. So this is this equivalent of square root 1 over square root 2. What's the square root of 1? Okay. And then square root 2 stays on bottom. But we need to rationalize it. And you should all know that that is the equivalent of root 2 over 2, right? Remember from the last school day that the little plus or minus, I'm going to change colors and draw a note. This means any quadrant. You're checking all 4. So don't let that throw you off. Luke, stay away. Okay, so now it's a scavenger hunt. You do have a little bit of thought process to take care of here. This says, where is the tan of some value equal to 0? Remember, tan is not on the unit circle. Sine and cosine are. Tan comes from what? Tan comes from y over x. And this is saying that when you find y over x, you end up with 0. That's what it's saying. Okay, so now you have to remember the rules of dividing by 0. When's it allowed? Like, when is 0 allowed in a fraction and the answer is 0? When it's in the top. And if you forget that, just go to your calculator and do 0, but divided by 2, or 2 divided by 0, and you're going to find one of them's an error, right? Or you can just remember when it's okay to divide with a 0 in the fraction, and when it's a no-go, when 0 is in the bottom of the fraction. Okay, so if I'm dividing y over x and I'm getting 0, then that tells me that the y value has to be 0. Does that make sense? That's the only way to divide with a 0 and get 0. It's a stretch there if you're not with me. So now you're looking at your unit circle and you're trying to find where is y 0. So where is y equal to 0? It's at, so this is, we're solving x equals, it's 0 pi and pi. All right, now we're going to come over here. Where is x root 2 over 2 or negative root 2 over 2, which means you should have 4 answers. What are they? You got pi over 4. You're hitting all the 45-degree reference angles. 5 pi over 4 and 7 pi over 4. All right, so y'all know me and my OCD. So I would say, now you can box those in and say you're done. I would come over here and say, all right, here's my answers. I got 0 pi, pi over 4, 3 pi over 4, pi. I like to put them in order. Doesn't matter. You don't have to. This is just my, what's it called? Idiosyncrasy. Okay, go to the next one. You should be able to do it. What's the technique? What's the approach? What's the approach on this one, y'all? You're going to factor the GCF. You could change this to what letter to make it less busy. You could change it to X, right? You don't have to. There's really not a lot going on here. You may see it without changing it. They have a common factor of what? Cosine. So I'm going to divide a cosine to the front, and that would leave me with a binomial of what? Then I've got the zero product property. Get the trig function by itself. Now we're ready to say on our unit circle, where is cosine 0? That's at what? 90 degrees and 270. Now notice the directions. They say this and this, which means they want you to answer the radians and they also want you to answer the degrees. So what I did was I answered in radians first. Then I went and wrote my little final answer and I just put the degrees under it. Where on the unit circle is x equal to 1? It's at 0, right? So here's my radians. Here's my degrees. Okay, go to the next one. Cosine of 2x plus sine x equals 1. This is a problem. I can't possibly solve my trig equation if I've got a double angle in there, right? Because we're trying to get it down to a single trig of a single angle, and then we can find it on the unit circle. So we're going to substitute one of the expressions for cosine of 2x into this. Let's think smarter, not harder. Go to your formula sheet. You have 3 choices for a cosine double angle formula. Don't write this down. The first one is it cosine squared minus sine squared? Okay. The second one is it squared? And then the last one, okay, so you have either this one, or this one. You have three choices. What's the rest of the problem? What's in the rest of the problem? A sign. So which choice would be more manageable? The second choice, right? Because it has just sign in it. I don't want to throw the top choice or the bottom choice in there because then I'm not gonna be able to get anywhere. So because the equation only has a sign already in it, let's use the formula that is just involving sign, because then we have the potential to have a GCF. We can pull it out, we can set it equal to 0, and move on. So I'm going to highlight this one. Now I know I said don't write this down. I didn't want you to write the whole thing down, but I do now want you to say on your paper, let cosine 2x equal this, or recall, whatever. So where there's a cosine 2x, I'm now replacing that with 1 minus 2 sine squared x. And I'm replacing it over it. And then I'm copying the rest down. Now, when you first look at this, you're probably just even more confused now. But what do you notice about the left and the right? The ones cancel. You notice that? This one's positive right here. This is a positive 1. Remember the approach on every one of these is you need to get everything to one side. So if I come over here and say minus 1, and then I come over here to its like term and write minus 1, you should notice that they go away. Now that 2 is still negative in front of the sign, so don't just all of a sudden change that to a positive. All right. How many terms are here? There's 2 terms. What do you notice they both have? They both have a sign. There's 2 ways to go about this. We will still come to the same answer in the end. Because your leading term is negative, you could factor a negative sign to the front. It will change the signs of the terms. You don't have to. In fact, I'll show you the approach without doing that. So if I pull a sign to the front, right, by division, then my 2 terms, now divided and a sign out, would be left as negative 2 sine x plus what? 1. You're at the zero product property, same steps as before. Set each equal to 0. Solve by getting the trig function by itself. So this one's done, right? Here I need to do what first? Subtract the 1, divide by 2. What did I leave out?
Negative 2.
Thank you. Positive 1/2. Let me write this because someone's going to say where'd that go. There you go. Now it's looking fine. Go to your unit circle. Remember how to ask yourself these questions. This is saying, where is y 0? Well, if y is 0, that means you never went up or down, so you're hitting those 0 pi and what's over here? Pi. Alright, this is saying where is y positive 1/2? Wait a minute. Pi over 3? Yeah, I got pi over 6. The y value. And then what's the other one? 5 pi over 6. So, just me in particular, I like to box it all in and say, here's my answers. Okay, go to the next one. Last one, right? Thanks, yep. Okay, what's the problem here? You've got a secant in there with a tangent. Now, there's no double angle, right? But they're definitely two totally different trig functions. I don't see a GCF. I do see 3 terms, which makes me think I have the chance of an A times C factoring approach. I definitely don't want to do that with a tan and a secant. This is tan squared, right? Go to your formula sheet and look at your Pythagorean identities. Yep. So come over here. Let's make a note. Formula sheet. Tan squared is secant squared minus 1, right? Did I copy that straight from you? Or did I shift? Okay, then I need to explain where I got the shift. Okay, hold on. Tan squared is what? Or what's it start out as?
1 plus.
Okay, let me start with that. 1 plus tan squared is secant squared. That's on your formula sheet. If I take and subtract this 1 there, then I get that tan squared is secant squared minus 1. And now, if I take that and plug it in, now I have just secant. Right? So I'm going to highlight this, and I'm going to come right here and highlight that to show that I'm going to replace tan squared with secant squared minus 1. Now there's nothing in front of it, so you don't have to put parentheses around it. And then I'm going to copy the rest of the problem. There's no shifting going on, but we do have 2 things that will combine. What is it? The -1 and the -1 are on the same side, so they become -2. And where should it go in terms of my problem? It should go at the end. So we've got secant squared plus secant minus 2 equals 0. Now, once again, you are having a hard time understanding how to solve this when it's in the trig form, change it to just like a U substitution. Secant is not x or y necessarily, right? It's a reciprocal function. So let's don't use x or y here because we don't want to confuse ourselves. So what I'm going to say is, for me personally, I said, let's secant be, and then I just picked a letter. I said M. So now I can see that this is actually just M squared plus M minus 2 equals 0. Which should look very familiar with the warm-up preview of the rest of the roots question. That's a trinomial, it's quadratic, and it will factor. There is an understood 1 right here. So when you do A times C, you get -2. Factors of -2 that add up to +1. +2 and -1, right? So go to your parentheses. Hey, remember what I said. When A is 1, your parentheses are done. Like once you get there. There's no GCF to divide away. Copy the terms. So you got AX. I'm just going to put the M. And you have AX. And you take your numbers. You got +2 minus 1. Zero product property. Solve. When you get it down to that single letter that you just used as substitution to make life easier, it's time to go back to the trig function. So this becomes secant x equals 2 and secant x equals 1.
Isn't it -2? It's -2.
Thank you. Good catch. Because that would have thrown the answer off. Okay, you can't find secant on your unit circle, right? So you have to calibrate it to the reciprocal function. So if this is how you think of it. If the secant is if the secant is -2, I'm going to draw an arrow to say like that my thought process is, then the cosine would be -1/2 or 1 over -2. That's where that comes from, 1 over -2. All right, so here, if the secant is 1, then the cosine is, wait for it, 1 over 1, which is just what? 1. So that one doesn't change. So now you're saying on the unit circle, where is cosine -1/2? Two pi over 3 and 4 pi over 3. And then where on the unit circle is x1 at 0 pi? So y'all know me, 0 pi, 2 pi over 3, and 4 pi over 3. So at this point, we're done with 7.5 homework, or notes. You should be able to finish 7.5 homework by tomorrow. I'm going to remove question 5 from 7.5 homework. It involves the quadratic formula, and I don't anticipate to use the quadratic formula. Tomorrow, I will be giving you back your corrections, and you will be going off of what you got wrong on your corrections to know what you need to study for the exam. It would be rushed if we had the exam on Wednesday, so the exam will be Thursday, because y'all need to see your corrections, like, you know what I mean? Yeah, let me pause this.